Hey guys, it's John here from Hometown Auto. Welcome back to the channel. I got a 2006 4Runner set in here, and the customer complaint is it will not start after it gets hot. And I hate these kind of problems, but I'm kind of on a time crunch because it's actually acting up at the moment. So let me show you real quick. Key, nothing, no click, no nothing. So I started troubleshooting the starting circuit. I'll take you along real quick. I think I found the fault, but I'll show you what the steps I took. Okay, I'm just going to voice over this section right here. What I'm doing is just making sure the fuse has power when the ignition switch is turned on. As you can see in the diagram, that's the way it's designed. In this clip here, I'm actually checking the relay circuit, making sure that it has a control from the PCM and making sure it has its power. And what I found out is it actually does not have control from the PCM. So after that, I started to investigate why the PCM's not getting its proper inputs to let this engine start. Now I'm like, oh no, this ain't gonna be simple. So I keep doing tests. I figure it's a voltage drop problem because when a car gets hot and acts up, it's usually because there's a voltage drop. I don't know. Voltage drop, the most simple way I can explain it is it's like a resistance inside of the wire somewhere, like corrosion, a loose connection, and it actually will steal some voltage, like a light bulb, and it will not let the circuit operate correctly. So what I did, I looked back at the wiring diagram. I'm thinking, what do I need to go next? So what I wanted to do is go to this. I didn't want to dig out the PCM. I was going to go to the part neutral switch, but I discovered the PCM is pretty easy to get to. So I got on this wire here. I back probed right into the back of this wire at the PCM. This is your part neutral wire. So if you go over into the component connector, it basically tells you, I know it was on E5 pin 8. So I found it real quick just to save you some time. There's E5 pin 8. And it says with the ignition switch on, it's in park neutral, it should be below 2 volts, that pink wire. With the ignition switch on and shift lever in park or neutral position, it should be 10 to 14 volts. This is what I found. So we should be looking for basically under 1 volt, under 2 volts, or over 11 volts. So I'm with my meter here, I'm on ground with this wire. And then I come over here to the other side where the PCM is. And I back probed into that wire that I just showed you. And right there is my probe, right there. To make this more simple, basically I'm back probed into the circuit to the PCM from the park neutral switch. And when it's in park or neutral, I should have under 2 volts. If it's in any other range, I should have 12 volts. So according to service data, when this is in park, that should be 0 volts or under 2 volts. And then when it's in reverse or drive, it should be 11 or 12, over 11 or 12 volts system voltage. That's park, reverse, park, reverse. So as you can see, I'm switching it back from park to reverse. It should be going from under 2 volts to system voltage. Okay, what I'm going to do is I'm going to heat up the park neutral switch with a heat gun. And I have a meter here. And I'm going to watch the meter. And my theory is if the park neutral switch is getting too, if it's faulty and when it gets hot, it's causing too much resistance, I feel like this would be the quickest way to determine if it's the park neutral safety switch or a wire, because it'd take a lot longer to track down a wire than to just heat up that particular area. Because when this thing gets hot, this voltage goes up. So it's telling me that the ground is, it's just not working properly. It's getting a bad ground, or there's too much resistance because of heat, or a bad wire, a bad park neutral safety switch. But if we heat it up with the heat gun and this starts to go up, then I know it's right there at that area. So let's try that and see what happens. All right. Oh, I gotta flip it. Okay, I'm heating up the park neutral switch. I've already been heating it up for about 30 seconds and the voltage is rising. We're already up to 12 volts. Oh my, no, we're at 1.2 volts. Let's just keep heating it up and see what it does. Hold that on. Yeah. Just
1.3. Now I wonder if it'll start if you...
I bet it won't start now. Once it gets over 2 volts.
No, you're...
What's it at?
Right now it dropped down to 1.4.
It went back down?
Yeah. But it was staying at 2 point... It goes to 12 volts. 12 volts?
12 volts?
Yes.
It just jumped up. All right, now you're gonna see it ain't gonna start. So keep that camera, keep that camera rolling.
Yeah.
Hold on. No start. No start. Okay, guys, it's been about a week since I had to order the part, the transmission range sensor. It came in. This is the part number. I got it upside down. There you go. And so we're going to install it on this Forerunner. And it's been so crazy here at the shop. I can't remember all the details. I know that we heated up the sensor and the resistance changed. We heated up the transmission range sensor, and so I diagnosed it as a bad sensor, or a bad range sensor. So I'm going to install that, and then we're going to take the heat gun and redo the test to make sure I didn't make a mistake. This thing was a real pain to get off. I had to beat it. The lock washer was froze up, so it took me quite a few minutes to get this off, but I'll speed through this part. All right, I'm gonna start it up. Make sure it goes in all the gears. It may need adjusted, the range sensor. I don't know yet. Well, that's not good. Uh-oh. Now it's not starting. Why is it not starting? Okay, so I'm sitting here fumbling around thinking, why is this new transmission range sensor not working? And I was getting ready to do the voltage check at the PCM like we did earlier in the video, but I was really starting to think that it's got to be in a wire, because I got a brand new range sensor, and when I heated it up with a heat gun, it got hot and the voltage went to the roof and it wouldn't start the Forerunner. So I've been fumbling around, and I started doing a drag test with the connectors, where you stick the pin, you find the same size pin and you stick it up in the connector to the range sensor and see if you're getting good connection. They should not fall out. So I was doing that. Here, and they all drug really well. None of them fell out. I went through every one of these. So I thought, what's going on? So I looked at inside the connector, or the actual range sensor, and I don't know if you can see this, but this is what I found. If you look really close, I see some green corrosion on that very end pin. This one on this end, on the bottom, on the very end. And I thought, let me inspect that wire closer, and I'll give you this is exactly what I did. And sometimes if you think there's corrosion, you want to pull on the wires. So I was pulling on them, see if it's corroded. You know, you tug on them, pull on them here, and sure enough, this one right here pulled right out. Can you believe that? It's the connector, for crying out loud. I never would have guessed that, but I should have been more thorough. Well, crazy. I should have checked the connector. I should have really looked closer at it. But it's no big deal, because I've seen them range sensors. They got a lot of resistors in them, and I've seen them go bad. But I did a slight misdiagnosis, but that's okay. We found it, and that's all that matters. I'm gonna see if there's a connector close by. Hopefully there is, and we'll get that soldered up, and then we'll do it again. I'll get back with you next time I turn the camera on. It may be in a few hours, it may be in a few days. Okay, here it is. 2 weeks later, I finally got the plug. Actually, it might be 3 weeks. I mean, my beard's probably longer. Luckily, the customer, I know him really well, but Toyota does not just sell the plug. They want to sell a repair kit for it, which is, I'm not fooling with that. And because you have to add another hour labor. But anyway, here it is, the park neutral switch harness, and I'm going to solder it up and see if it works, which I'm confident it will. We'll go from there. Okay, I didn't video the actual repair, but I will show it to you. There it is. I put new loom on it, soldered this connector in, put some Tessa tape on it. So that's all new loom. It was really hard to solder it up in here. I mean, I couldn't have probably filmed it anyway. Let's see if it starts. All right. All right, I'm gonna let it heat up. Okay, the truck's running, I'm letting it heat up. And we're back probed into the wire. And before, when it heated up, this wire would go up to 2, sometimes even 10, 12 volts because of the bad part neutral switch. Just to remind you, I'm back probed into the PCM signal wire from the range sensor. If this is over 2 volts, it will not start. So far, I've been heating it up for about 5 minutes, and it's still looking good. I'm gonna let it set here and idle. "20 minutes later, still no change. Well, that's a fix, and it took forever to get the parts. This car's been here for way too long. These connectors, part neutral switch wasn't bad to get, but anytime you try to get a connector for a Toyota actually don't even make connectors. You have to get a D-pinning kit, and I just rather just put a connector on it like most cars. It's a lot easier, and you get in there and mess with them D-pinners, and I mean, I could do it, but I'd just rather put a connector on it, because I'd have to D-pin the whole thing and it could take hours. So a connector and a part neutral switch, because of corrosion, was the problem. And I appreciate you guys watching, and stay tuned. We'll get some more fixes on the way, and that's it. Y'all have a good day. Later.